Hey there, friends. This is Kevin from Happy Coding here. Over the last few days, I've been participating in an event called January, and if you've followed any of my other videos, you have seen me work through a couple of those. All of these examples are from January, and you can come to Happy Coding or watch some of the previous videos for those. The idea of January is every day in January, you get a different prompt that inspires you to create something new every day. And like I said, I did a few of these so far, and so I'm going to continue with that tonight and today on January 26th. The prompt is 2D perspective. And what I think I'm going to do is play with something that I honestly have no idea how to do or not really a good idea anyway, and that is the idea of like an isometric perspective. I don't know what an isometric exercise is, but I mean isometric perspective. And you've probably seen this before. It's pretty popular in like a lot of like mobile games or even like different kinds of like architectural drawings. But the idea is that you draw a three-dimensional object in two-dimensional space using a certain set of rules. And let me see if I can come up with like a good example. So like, yeah, you can see this in like certain kind of video games that where this is like an isometric perspective where the shapes follow a certain pattern. And this was also pretty popular in certain kinds of art. And let me see if I can find that, like MC Escher. So you've probably seen like this painting is very popular, and there's kind of a paradox introduced by the isometric rules that this painting follows, where the tiles of the painting are kind of laid out in a grid, but that grid, if you follow the rules of it, it kind of leads to these weird patterns where you're not sure if this is going up like in height or if it's just going back like further away from you. And it's kind of a limitation of the isometric perspective, but it also leads to these like really cool, really trippy kind of patterns that I really enjoy. So like I said, I don't really know what I'm doing here, so this video might end up being pretty frustrating for both of us, but yeah, here's another example of kind of the isometric trick where you can have like a staircase that never ends because you're not sure if you look at any particular section of it, you're not sure if it's like, is this step going further away or is it going higher up? And I think that's really interesting, so that's what I want to play with. So I looked this up on Wikipedia. This is about as far as I went, honestly. And it has some examples, and yeah, maybe I should have started with this because that's a better example, where there's kind of this paradox introduced, and I think that's really cool. And here's maybe a good example of why it's a paradox. Like if you just follow the rules of the drawing and you look at only like one section of it, you're not sure exactly what it's representing. So like from here to here, that kind of looks like you're going up vertically, but when you look at from here to here, it looks like you're going back kind of further away from the camera, as it were. But if you look at the whole thing, then you realize that something doesn't really make sense, and that's because of how things are laid out in a grid. And like things that are further away, they don't actually get smaller. So that's another kind of trick that your mind doesn't quite understand. So that's kind of the idea. I'm not sure where I'm going to go with it. Honestly, I just have this vague notion of doing like an isometric projection and playing with it. So we'll see how it goes. But I did spend a good like hour staring at this picture yesterday, I think it was, trying to wrap my brain around what exactly an isometric shape is. And so I'm going to focus on the cube because I think I can do that in a reasonable amount of time. And If I stare very intently at this, I can kind of recognize that the cube itself is actually a hexagon, and it has these kinds of rules that are kind of internal to itself. So by that I mean, if you look at the length of one of the like sides of one of the squares that make up the cube, we'll call that like 1 unit. So that's 1 unit of height or width or length or whatever. And you can then kind of look at the relationship between that unit of 1 to the rest of the sort of hexagon. So if this is 1, then the whole width of the entire hexagon is square root of 3. And so that's like the whole width of the thing. And like now I'm staring at it and like I'm kind of now I'm unsure, because now I don't even know like what's the square root of 2. Square root of 2 might be this dotted line. Is that what it's trying to tell us? Like I said, I have no idea what I'm freaking doing, so we'll hope for the best. But I think what I can do is, what I'm going to end up drawing is a hexagon, and then the real trick will be spacing the hexagons out in a grid, and that'll be where it gets really confusing for me. So I'm gonna probably refer back to this quite a bit, but for now I'm going to jump over to my P5 editor. And I haven't written any code, I haven't prepared anything, but here we are. We've got a gray square. So from here I want to, maybe, I'm thinking of a few different ways I could do it. Maybe I'm just going to start with a function, something like draw cube, and it's going to take like an x and a y, maybe a width and a height. For now I'm actually going to say just x and y. And I want my x and y to be this point right in the middle. So the x and y, you can think about it in a few different ways, but if you think about like the 3-dimensional nature of the cube, then the x, y will be the coordinate furthest away from the camera. So it's like the back corner of the cube. And so it's also the center of the hexagon in like 2-dimensional space. So I can kind of cheat and draw a hexagon, and that will represent my 3D space. So let me maybe think about something like, well, first I need to use proper syntax. So if this is 1, then I need to kind of define that like multiplier. So let me think about like const. Maybe I'm going to call like side length equals something. Maybe I'm going to start with 100. So this is now 100, and I can use this side length to calculate everything else. So I have 0, 0 is right here, or like x, y. And so what I need to do is calculate these 1, 2, 3, 4, 5, 6 points, and then draw lines between them. So I could start in a few different places. Maybe let me just start up here. Let me think if that makes sense. So the other thing I can do is use a little bit of trig to calculate some of this, and maybe I should have prepared like the pictures that I need, but yeah, I don't know what any of that means, and I don't want to, but I just want to make something that looks kind of cool. So yeah, I think maybe this is what I'm looking for. Isometric drawing of a cube, yeah. So this is 120, which makes sense because there's 3 of them and they should add up to 360. And that's annoying, whatever. So I'm trying to figure out like what is this point, or what is this point. So this would be 0 from xy all the way to the right would be 0. So what would this be? Well, I can figure this one out because that's just 90. And then I can add 120 to that to get where I need to be. Is that right? Yeah, maybe let's just think about this. So maybe I should have drawn this out with a piece of paper, but I have my variables, my angles. 90 is going to be this one. And so what's 90 plus 120? That's like 210, 90. So I'm going to forget these numbers. So 120 is each angle. So 90 plus 120 is 210, I think. And then plus another 120 is just going to be 330. Is that right? So is this one 330? I think it is. Okay. So that makes sense because this is 330 and then this is 360. So I think that means that this is 30. This is 30 degrees. And I could calculate it all in degrees, or I could, what's 30 in radians? 30 degrees to radians. Is that some obviously easy number? Is there like I want it in terms of pi. I am sure, oh, it's so it's 30 divided by 180, so it's pi divided by 6. Is that right? Well, we'll find out, I guess. So I've talked a lot and I haven't written any code, but I think what I want to do is I'm calculating this point down here. So maybe what I want to do is like const point, I don't know what to call these, so I could maybe store this in an array or something, but like I'm just going to call it like p1 for now, equals, so it's going to be x plus cosine of pi divided by 6 times, and what do I need it to be multiplied by? I need it to be multiplied by this dotted line, and I'm not sure from this drawing whether that's supposed to be 1 or if that's supposed to be square root of 2. For now, let me just try 1. So times side length. I might change that. And then, so that's P1x. And I'm going to change that at the variable in a second, but I just want to double check that everything I've thought about so far is remotely close to right. And if not, I might turn this video off and eat some ice cream and go to bed. So I've got my x and y, and maybe let me just draw a line from xy to p1x, p1y. And let me maybe draw, I think call draw cube with like mouse x, mouse y, just so I can get a good idea of like exactly what's happening. So what I should see is as I move my mouse around, I'm hoping that what I see anyway is this kind of line from my xy, which is in the center, down a little bit down to here. And let's just see. And yeah, I think I do see that. Cool. So maybe using mouse x and mouse y was a little bit silly. Let me just move it back to the middle. And I think I do see that. I'm not sure if this should be multiplied by square root of 2. Not even sure if square root is a function. I think it is because it's getting bold. I don't think it's going to be a huge difference by itself. Yeah, I think that looks. I mean, I don't know what I'm basing it off of. That looks too big though. But we'll see. I might add these back. I might not. Like I said, I maybe should have done a little bit more research on this, but I'm literally just going from this diagram and hoping for the best. But here's what I can do. I think I'm trying to figure out what to call these variables because like I'm going to need 6 points, and I don't want to put them in like P1, P2, P3. I think what I'm going to do is maybe create an array. And let's see how I feel about that. So what I would do is const points equals an array, and then do something like points dot push, and then what I could do is create a vector. What's the function for that in P5? So I'm looking up in the reference for like, I know there's like a p5.vector, but I'm wondering, yeah, create vector, okay. I could call new p5 vector too, I think, but whatever. So I'm going to create a vector with this number, x, y, x, and y. There's probably a bunch of different ways to do this, but I think this will make my life a little easier in the long run, and this formatting is kind of annoying. But whatever, there we go. We have a vector, and now it only contains a single point, and that is the point that we already used. So let me do something like points0.x, points0.y. And nothing should change except for this will get a little shorter because I removed the square root of 2. And there you go. Okay, cool. So that'll be maybe a little bit easier to work with. So now what do I want to do? So I've got this point, and I did that because over here is 0, and I'm going around sort of clockwise from 0. So that's the next one. So this one's going to be 90 degrees, which I think is pi over 4. So I can kind of just copy paste this. There's probably a better way to do this, probably with a for loop, but until I kind of recognize the pattern, I'm not quite comfortable with that yet. So points 0, points 1. So now I should see another line that kind of goes from the center down. And I do not. Why not? Because that's not pi over 4, is that right? Let's see. So no, it's pi over 2. It's pi over 2. So yeah, I'm thinking in radians, where this is 0, over here is pi, and then 360 is 2 pi. So yeah, 90 degrees is pi over 2. I trigonometry and like radians and stuff, they don't come naturally to me, so I'm probably going to get them wrong quite a bit, but this looks right so far. So I've got my this guy, this one. So I'm going to keep going, and now I need this one, which is going to be, well, it's 90 degrees plus 30, so it's 120, which I think matches what we said before. No, it doesn't. Well, it does, because it kind of makes sense that it's going to be 120, because it's 120 off of something. Off of this one, though, right? No, okay, it's 120 off of the outside ones. So it's 120 away from this one, actually. Wait, no, okay, I get it. Yeah, it's 120 away from the first dotted line. No, that makes sense, actually. So what is, what did I say this is going to be? The whole thing's 120? No. If this was 30, then this is going to be 150. Because this is 30 plus another 120 is 150, right? Oh man. And let's see. So I could. So what's 150 in radians? And I wish it would. I guess I could probably figure it out. So it's 150. So it's 15 divided by 18, which is what? 5 somethings. 5/6? No. Yeah, that makes sense. 5/6, because it's not quite 1. Okay, now that rings true to me. Pi times 5/6, something like that. Okay, good lord, this is a rough one. But hopefully what this means is we have our sort of third line. And we do. Cool. And I think what I might try to do is just freaking use a for loop, because I'm pretty sure that this is going to be a pretty patterned thing. So I start at 30 and then I add whatever the value is, pi over 6, pi over, no, it's not quite right either, because this is not quite halfway to this. But I could start with the outside. So if I start with this and then, so I start with 30 and then I add 60. And then I add 60 and then I add 60. Is that right? I think it is. So let me maybe start over a little bit and say let angle equals, and I want to start it at what, pi over 6. And I want to go to angle is less than, I think I can just do pi times 2 or tau here. I think, because it'll never try to be exactly 2 pi, I don't think, no. So I don't have to think too hard about exactly what it needs to be. And then angle plus equals, I don't remember what I said, but is it pi over, so it starts at pi over 6 and then it needs to go 60, and that's pi over 3, I think. Man, I'm not good at trig. But what I can do is something like this, where I say points dot push, and then I go to, instead of pi over 6 here, I go to angle here. And to test that, what I can do is just run this again, and I should see nothing change. Oh my God, that's amazing. Okay. I was really suspicious of that. That's a lot of like me guessing and hoping for the best, but it seems to have worked out. But I can keep going, and I could, again, this could be a for loop as well now, and I think eventually it might be. Actually, I think, and we'll see. But 1, 2, 3, 4, and I need 2 more, 5, 6, I think. Well, we'll see. 1, 2, 3, 4, 5, 6, 6, 5, 4, 3. And so that's 6 points. So I should see 1, 2, 3, 4, 5, 6 lines sort of snowflaking out of my center. And I do. Cool. But something's broken. Oh, it's because there's no 6, of course. Because 0 counts as, so it's 6 total points. Without there being a 6th index, because 0 counts as 1. All right, but here we go. I'm already pretty happily surprised by this one. So I've got my sort of 6 points, and right now I'm just drawing a line from the center. And now what I want to do is sort of draw the faces instead. And so let's see. I think I might kind of do that manually, or I could, maybe what I'll do is use the quad function so that I can then color them later. Yeah, I'm gonna use quad. So I think what I'll do is maybe I'll change this, because I'm going to have to pass in a whole lot of points. Actually, no, I'm not. I'm just thinking of formatting my code, honestly, and I think I'll just use some white space in a second. But I've got my points, and now what I want to do is draw a bunch of quads. And so I'm going to have something like quad for, I don't know, let's maybe start, does it matter? No, it won't matter, because they don't overlap at all. But let's start with the top, I guess. Actually, let's start with down here, because that will use my first point. So I'm drawing this quad, and let me start with this point, because that's going to be points 0 dot x, points 0 dot y, and then what's my next point? My next point is, well, my next point actually, so it goes to points 1 dot x, points 1 dot y, and then it goes to my center, so that's just xy, and then it goes to the rightmost one, which would be my last point, which would be points 5.x, points 5.y. I don't know if you can hear this, but there's a train very loudly going in my background. Sorry, that's some real coding environment for you. But let's see. So I have my quad, and so what I hope to see is this quad being drawn. And cross your fingers. And oh man, I think I do. I think I draw a line over top of it, but that's okay. Yeah, man, cool. I still am not sure if I need that square root of 2 in there. We'll cross that bridge in a second, but I think this is working. So we've got our sort of lower right quad, and I'm going to keep trucking with this. So now I need this guy. Let me maybe start at, maybe I should have started in the center for each of them, just for like symmetry. So actually let me really quickly change that, because it's really easy change. It doesn't really matter. This is just to hopefully make it a little easier to reason about after I have all of them sort of working. So nothing should change, and nothing changes. Cool. So now I have kind of a rule in my code here that I'm going to follow, that all of my points or all of my quads will start with x, y. So I can do that. And now I just need to figure out like what my next point is. So I'm doing this one. So my next point is, that's 1. That's an index of 1. Points 1.x, points 1.y. And of course there's a really easy way to test that was right, but I could draw a line or something, but whatever. So that's points 1. I think then we'll go to points 2, and like I said, maybe this could be a for loop, but I sort of don't trust myself to get it right yet. And I think that's going to be points 3 actually. So yeah, maybe it really could be a for loop because it's just in order, but whatever. Okay, so now I should see sort of this part of my fake cube being filled in. And I do. Cool. You kind of have to squint to see it. Right now it kind of looks like an open book, like opening the wrong way. I guess that's kind of up to how your brain interprets basic shapes, but to me it looks like we're looking on the inside of something, but whatever. I guess that's just true of these kinds of shapes anyway. So last, I need to go to x, y, and then start with the point I just ended on and then go around. So I think I can probably figure this out on the fly. Let's see if I can do it without going back to that drawing. So it's going to start at 3, go to 4, and end at 5. Is that right? I don't know. Let's just run it. Yeah, it is. All right, cool. So I actually think that's pretty right. I think that's exactly what I was going for. The one thing I might check is, do some of these need to be square root of 2? And you know what, man? I think I don't care. I think it looks good enough for my purposes that I don't need it to be exact. Is that true? No, those are all going to be 1, I think, because this is like a, what's it called, like a regular hexagon where each of these spokes is the seam length. So yeah, I think that's 1. I'm not sure what this square root of 2 is. I should probably figure that out, but so maybe what's the red supposed to represent? So there's like black and red on each of these. So what's red? Is there like an explanation of this? No. Like I said, I probably should have researched this a little bit. if I Google like square root? No. Someone who understands like the isometric perspectives is probably like screaming at me, and honestly this video is probably not for you. But so if the whole thing is square root of 3, you know what I'm going to do? I'm going to pause this video for 1 second and I'll be right back, and I'm going to do just a little bit of research. So for you it'll only be like 10 seconds. Okay, through the power of time travel and video editing, it's only been a few seconds for you, but I feel kind of dumb because this page, I actually have not left this page. This page explains exactly what the numbers mean. So black labels are the like underlying the 3D object. If it was real, that's what that's the dimensions it would have. While the red labels are the dimensions of the 2D projection, which is what we're actually drawing. And so I basically don't care about the black labels, because the black labels are like what if this was a real life object, that's the dimensions it would be, but we draw them a little differently, and I only really care about the drawing dimensions. And so I think that means that I can not care about the square root stuff. Is that true? So the only square root thing that's red, which is the 2D projection, is like the width of the whole thing, and I'm pretty sure I don't ever have to care about that. So yeah, red labels are the 2D thing. So this is 1, which is the length of one of these spokes, and that's all I care about. It so happens that this whole thing is square root of 3, but that's not important to me, so it doesn't matter. So so I'm done. So I don't care. Cool. So I don't need to worry too much about that. That was a little sidetrack. So this looks pretty cool to me. Now I am freed up to kind of, like I said, I didn't really have a plan, but my goal was to draw something isometric and then play with it. So I have this isometric cube. I could play around with this. I could add some colors or something. I kind of want to play with the idea of trying to lay out a few of these. So how do I want to do that? The isometric shapes are generally placed into some kind of like a grid. So let me see if I can find something like that. It's kind of gross looking. But let me just see if I can find one quickly. No, there's actually a game that I play that like partly inspired this. Let me just really quickly maybe try to find an image search of that. And yeah, you can kind of see from here, this is an isometric view that's used in a video game, and you can see that it's kind of laid out in this grid form. And so I kind of want to play with that idea where I'm just kind of putting cubes in a grid, or fake cubes as it were. So it's kind of the direction I want to go. So I could do something like a 2D array or something. I could kind of just throw different numbers at this. I think maybe what I'll do is, instead of taking an X and a Y, well, it could be X and a Y, but now it's like X and Y of the grid. Yeah, kind of like that. So maybe I'll do like row and column, or column and row, column, row, maybe something like that. Maybe I'll shorten it to C and R. So then what I want to do is const X equals, and let me think about this. So I kind of want my my 0, 0 to be in the very tippy top. And so what I might need to do is define like a grid top and a grid top X and grid top Y, something like that. So const grid top X equals, let's call it like width over 2. Put it right in the middle, and then const grid top Y equals, for now let's maybe put it at 100, so it'll be kind of like up here. So I could do, so let me do like 0, 0 here. So I'm passing in sort of the row and the column, and so that's 0, 0 would be like this very top one. And yeah, I think that'll work. And then to figure out X, then I need to use a little bit of trig and say cosine of, oh man, what is the angle of sort of the first spoke, or the angle from here to here, which I think is going to be the same as the angle from here to here, which was what, pi over 6. It was whatever we used in our for loop, pi over 6. Is that right? As you can tell, like I said, I'm not super great at trig, but I think it's right. So cosine of pi over 6 times what? Times c times side length, actually, times c times side length. So times side length, and I might move this to the top as well because all my cubes are going to be the same size, I think, because I don't know if I'm capable of anything else at this point. And let's do like a const y equals sine of pi over 6 times r times side length. Maybe. So what I have now is a function that takes, instead of an x and y, it takes kind of a grid-based coordinate. So like an index, so it's 0, 1, 2, 3, and same thing for like going down in the rows. And so what I can do is like 0, 0, and let's just see what that does. And it breaks, of course it does. Why wouldn't it? Why? Oh, it's because const side length equals 100. Yeah. Oh, it's because of width right here. So grid top X equals width over 2. Let's do let, and I might move the rest of those variables down, but for now, let's just try that. And that did not work at all because I didn't add my grid top X here. Grid top X, grid top Y. Cool. So that's not, oh no, that is what I expected. That is what I expected, because you have to imagine that my XY, or my CR, my 0, 0 is actually this point right here in kind of the center of my square, which kind of represents like the back corner of my square, or my cube. And so this actually is exactly where I expected it to be. So I could move it down a little bit. I think I will definitely decrease its size. And now here's where it's like make or break. Here's where whether this was a success or not. What I want to do is draw another cube at 1, 0. And what I should see, what I hope to see, is another cube right here. And oh man, not quite. That's really funny. It's kind of a cool looking artifact, but it's not what I expected, not what I wanted to happen. And I think it's because this number is wrong. I think it's not big enough. So I'm tempted to just try random stuff, but it needs to be, what does it need to be? If this is 0, 0, I thought it would be this number. cosine sine times c times r. I'm pretty sure that part's right. Let me maybe just try a couple things. Let's go back and let's do maybe draw a cube of 1, 0. So now I would expect that to be down here, but where does it actually go? What on earth? This is where this video turns into a 5-hour detour of Kevin Workman not understanding trig. I'm sure it's something in here, something messed up. Is it side length? Let me think about this. So I'm looking at this, and so let's say that I've drawn this cube at 0, 0. Now I want to draw a cube 1 to its sort of right. So I want its origin to be here, don't I? Pretty sure that's right. Do I want it down here? No, I want it over here. And to get to that, what I do is what I started my for loop at, which was pi over 6 times side length. That's right. All right, so again, through the power of video editing and time travel, I spent some time doing some research, and I think I understand what's happening again. So this logic won't work because we're dealing with an isometric grid. So as you increase your column and your row, you'll actually change both your x and your y. So as I increase my column, notice that my y value actually goes down as well. So I can't just base my x off of my column alone or my y off of my row alone. I have to consider them both. And so what I did is I Googled isometric grid to coordinates, and I read a few of these, and I'll call out a couple that were especially useful. One is this this isometric tiles math by Clint Bellinger. This explains it quite well, and you can read through this if you're curious, but like here's our normal grid, and I think my logic would have worked if we were in a normal grid, but an isometric grid is kind of rotated, and that's why when you go from 0, 0 to 1, 0, notice that your x changes, but your y also changes. Same with when you increase your row, both your x and your y change. So this explains the math, and it makes a certain amount of sense to me, as much sense as much math can, but you get this handy little equation that you can use. And the other function I used was, I think it was this, it was yal.cc. It was this page, and this also helped me understand what was happening. So like I said earlier, I think a big part of coding is actually researching and doing some reading and figuring out, what you're doing. So I started this with not understanding isometric grids at all, and I had to do a little bit of homework. And so let's think about this. So what I could do is kind of copy this into our code or my code and think about what it would be in terms of what we've been using so far. So my screen X, my screen Y is what I'm trying to calculate. I need to offset this because my 0, 0, I want my 0, 0 to be kind of in the middle. And then instead of using this like cosine sine logic, what I want to do is use my R and C. So X is C and y is r, because columns and rows. And then I want to figure out my tile width half. And another rabbit hole I went down when I was off camera is the fact that these are all about 2D grids, and I'm actually trying to take it one step further. Maybe I should have started with a 2D grid in hindsight, but I'm using this this sort of isometric projection in 3 dimensions. And so I need to think about what they mean when they say tile width half and what I'm actually using. So if I go back to this diagram, I can see that the width of the tile, and by tile I mean like the 2D, like one face of it, like this top face or this bottom face, is square root of 3. And so what I think I need to do is take square root of 3, divide that by 2, and then multiply it by side length, something like that. So my tile height width, or tile width half, is side length times square root of 3 divided by 2. Square root of 3 divided by 2. I'm trying to figure out if it's going to be square root of 3 or square root of 2, but if one doesn't work, I'll try the other. And then same kind of idea for my y. I need to do c plus r times, and this needs to be tile height, so it's going to be side length in there somewhere, times what? What is my height? So my height, I think it's actually just my side length, because this dotted line here is my side length, so I think I just need to divide that by 2. So it's like times 1 divided by 2, which is just divided by 2. So, oh boy, now I think that would work. And I think it does. Let me just double check. Does square root of 2 make any more sense? No. All right, square root of 3 it is. My head's starting to hurt from all this trig, but I think this works. So I see 0, 0. I see 0, 1 down here, and I see 1, 0. So maybe let me get rid of 0, 1, and I should see this one go away. And oh man, that's awesome, finally. I do. Let me maybe change this to 0, 2. So I should see it kind of move down. And great. I do. Awesome. So I could play around with this a little bit more. So draw a cube maybe at 3, 3. And yeah, okay. So that works. Cool. One thing I kind of want to play with. So now it's like, what do I do next? What do I do from here? So in hindsight, I should have just done this in 2D because 3D is rough. But I could use this somehow. 3, 4. So I should be like on this side of that last cube. Yep, cool. So this seems to be working. So I could play with this. I could just throw a bunch of numbers at this function and maybe add some random colors, and I think that would look cool enough. I'm tempted to kind of play with the 3D nature of it a little bit more. Add like a Z coordinate here. It's also getting pretty late for me, honestly, so I might call it a night here and pick it back up tomorrow. Let me just think for a second about what it would mean to introduce a Z value. So we have our X and our Y based on our C and our R, and if I introduce a Z, then for every Z, my Z does not change my X at all. but it will change my y. So let's just see if this is really easy, and maybe I'll end it there then. Let me add a z. Let's make this a little simpler. Just start at 0, 0, 0, and maybe draw a cube at 0, 1, 0, 1, something like that. And what I need to do is change my y based on my z. So if I go here, if I'm here, I think for every z, I move it up by side length. Is that right? So could I do minus side length times z? Is it really going to be that easy? I can't even format my code anymore. Man, it's been a rough night. Whatever, I'll format that later, I guess. So let's just try it. Oh man, did that work? So I've got a cube at 0, 0, 0, and I've got a cube at 1, 0, 1. I think that worked. Let's try draw cube 1, 0, 2. And so I should see one like right on the top of that other guy. Oh man, that's freaking awesome. Okay, so draw a cube, I don't know, 2, 3, 0. And okay, does this make sense? Yeah, it does, because like this is 0, that's 1, that's 2, then down 3, okay. And let's try, maybe I'll draw another cube at like 2, 3, 3, let's just see. Yeah, okay. And then let's try draw a cube at 3, 3, 1. So now I'm going to put a cube on top of that one. Oh, cool. I think this is working. So I've got, what do I got? I have my isometric grid, and I have my draw cube function working in 3 dimensions, kind of, you know, in the isometric fake way, but that's what I wanted to do. And from here I could do a bunch of things, but my brain's kind of fried, and I think what I am going to do instead of continuing on is I'm going to stop here, and you won't know this, but I will eat some dinner, go to bed, go to work tomorrow, have a full day, and then I'm going to come back to this tomorrow. So in the video, it will only be like 10 seconds. So all right, I'm going to shut up for a second and say I want to come back to this, and while I'm gone, maybe you can look at cat pictures. Oh, so look at these while I go have 24 hours. See you soon. All right, through the power of time travel and video editing again, it has been about 10 seconds for you, and it has been about 24 hours for me. So it's tomorrow now, and I've taken a break. I went and had dinner, went to sleep, went to work, and here I am again. So I'm coming back to this, and you know, maybe this video just turns into us looking at cat pictures together, but that's probably not why I came here. So let me go back to my editor and remember what my life is. Saved about 22 hours ago. Yeah, sounds about right. So cool. I have my isometric grid working, and I can draw a cube at a particular x, y, z. And that took me a long time, honestly. There's a lot I cut out of the first video that I just didn't record. And it took me a lot of reading and a lot of banging my head against some trigonometry and a lot of more reading and some getting stuff wrong. But here we are, it works. And now I think starts the fun parts of it, now that I have my little engine working. So from here, what do I want to do? So maybe let me think about what my actual end goal is. I had this kind of vague notion that I would play with a 2D perspective of like isometric cubes and get something interesting going. And right now I can lay my cubes out in this like 3-dimensional grid, but they're kind of boring. They're just kind of white and not very interesting. So I could add some colors. I could come up with maybe a pattern that looks really interesting, but I think I'll probably leave that up to randomness, honestly. But I think what I'll do is I'll maybe add some colors here. So I could, I could pass in as a parameter my color, or I could set my color in here and maybe call no loop. I think what I'll actually do is create a class. So a class that represents a cube that then handles drawing itself. So yeah, let me kind of convert this function into a class. So what I'm going to do is call a class like, I don't know, cube. And what do I need in here? I need a constructor, I guess, and that's going to take maybe a CRZ. And I think all that's going to do is say like this dot C equals C, this dot R equals R, and this dot C equals Z. Save that for later. And then what I might do is move this whole thing, this whole function inside that class. And then instead of having CRZ be parameters here, I'll use this dot C and this dot R and this dot Z. I'm going to probably miss this a bunch of times, and I'm probably going to mess things up, but whatever, here we are. Times side length times square root of 2. I'm trying to figure out where this would go. I guess the times should be down there. I don't know. I don't know if it matters. So we got this dot C, this dot R, I need this dot Z. Side length, I think I'm going to keep my cubes all the same size. I could maybe experiment with having them be different sizes, but I kind of like the uniform look. All right, let me just try something here. So let me say like, I might have like an array of cubes. So something like this, const cubes equals empty array, and maybe up here I say cubes dot push new cube, and I'll just start it at 0, 0, 0 just for now. And then in my draw loop or my draw function, I will say for const cube of cubes. I always mess up the JS syntax, but we'll figure it out. Cube dot, what did I call that function? I don't think I called it anything, just draw cube. So yeah, draw cube's fine, but let's call it draw. Let me clean up my code a little bit, fix the formatting. And yeah, okay, it looks fine. Nothing too gross. And is this all I need? Let's find out. So, all right, there's my cube. So now I can maybe play around with making sure this works. So like 0, 1, 0. So I would expect that to be down here, I think. And it is cool. It's really rewarding to see things start to come together after yesterday was rough. So 1, 1 will be kind of over here, I think. Yeah, man, cool. And just for funsies, let's try 1, 1, 1, and that should be kind of above my bottom cube there. And it is cool. And you can kind of see that like the cubes overlap, and that's actually intentional. That's part of like the isometric view. So maybe let's just see what happens if I add my back cube first. Let's see what that looks like. And yeah, nothing changes because a cube at 0, 0, 0 and a cube at 1, 1, 1 ends up being at the same place on our screen, and that's how a lot of the like paradoxical things come out. Like that's sorry, I can't type and talk at the same time. But that's how a lot of these like optical illusions work, because you see that you can't tell if this waterfall is going like back away from the camera or like up vertically, and that's because the cubes at certain locations kind of end up being at the same place in screen space. So it's actually like intentional that it works that way. It also probably means that I probably didn't need this Z. I probably could have figured out how to place my cubes on the screen like without that, but I kind of like having this kind of control over it, or controlling it through that through those parameters. So a similar idea, like this cube is at 1, 1, 2, but you kind of can't tell, like, is it at 1, 1, 2, or is it actually at 0, 0, 1? You know, is it right above it, or is it 2 above that one? You can't tell, and that's intentional. So from here, so I've got my class working, and that's great. And I think from here, what I might do is maybe let's start thinking about random colors. So let's think about how I want to do this. So I kind of want to have like a fake shadow effect, kind of like how this works, where the one side's darker and the one side's lighter. So let's play with that idea. So maybe I start out with like a this.r and a this.g and this.b. I don't love that my variable names are all just single letters, and in fact here, like the fact that I have 2 R's is not going to work. So maybe I call it red, green, blue, maybe. I could also call this like column, row, and Z, whatever. This will work. So what I might do is say, so I can get rid of these lines since I'm kind of drawing over them anyway, and I have 3 quads. Let me just say fill this dot red, this dot green, this dot blue, and let's just see what that looks like. So yeah, cool. I've got my random cubes, and that works. But they're not quite like the 3-dimensional beauties that I was hoping for. So let me maybe try a couple things. Let me maybe increase the size. Whoops, it's probably too much, huh? I'm going to move this back in a second, but just to have something a little bit more interesting. There's something. So right now, the fact that they're kind of, it's just like one color, you kind of can't tell, like you can switch back and forth, like are we looking at a cube or are we looking at like a sort of a box where this point is actually further away from us. And so I think that shadows kind of help with that. So I kind of want to try something really dumb here and just do like fill one color, fill another color, and fill another color, and those colors will be like multiplied, so like 0.75 here. So this one will be 75% of the brightness, and then the next one will be maybe 0.5. We'll see. Like I don't want the 3 colors to be like totally random, because that kind of just won't look like they're connected at all. But I also don't really feel like calculating like a brightness, because I'd have to like cap it at 255. Seems like a lot of work, so I'm just going to multiply by some numbers. And yeah, man, I think that's cool. So you can think that like the light is coming from over here, and you know, maybe it's shining that way. So it's kind of the opposite of how this works actually. So maybe what I'll do is switch those. I don't think it really matters actually. I think I'm kind of just copying the image from Wikipedia without thinking too hard about it, which might be okay, but I just want to maybe compare what these two things look like. So now the darker edge is sort of the one that's facing us, and you can maybe imagine that the light is coming from the top, and yeah, I guess that looks okay. I think maybe 0.5 is too dark. I also am not convinced that's right. No, it is, okay. So I might do like 0.6 or 0.75 and then 0.8, you know, something like that. But, you know, I could play with this. Let's just see what 0.9 looks like. Kind of don't want my cubes to be too dark because then they won't be very visible. It's kind of subtle, but it works. Whatever. I could play with that later, but for now, you know, I've got my cubes colored and having like a shadowy effect. I might play with that in a second, but let me maybe add my cubes back just to see what they look like with some friends. Yeah, I kind of like that. That looks cool. So next, another thing I could do is maybe restrict the random colors. So right now, I could have like completely black cubes, and it's kind of down to the randomness. It's fine. So I could go from here and like think about an interesting pattern. Maybe I could go for like an MC Escher type thing where I kind of try to make a waterfall, or I could try to do the infinite staircase thing. But after yesterday, I kind of am sick of thinking, so I kind of just want to leave it up to randomness. So what I could do is something like, let's see, let I equal 0, I is less than some number, 10, I plus plus. Really, I just want to loop a certain number of times. And then do something like const, so what do I want to see equals random of 10, but I want to floor that. Actually, let me keep it just that const. Or equals random 10. I'll show you what I'm talking about in a second, but and then cubes dot push new cube CRZ, and let me get rid of these. So now I'm going to add 10 cubes at kind of a random position. Actually, let me take that down to like 3. And yeah, I don't know where that third one went, but it's kind of just off the screen probably. So yeah, that kind of works. Let me maybe increase this back up to 10. And yeah, I mean, that's already kind of cool. But you see the sort of problem that I'm going to encounter, and that's like the cubes don't really line up. They're not really in a grid anymore. So you have this kind of weird like floating thing. You have this, they're like completely overlapping. That's just because it's all down to random like this. You know, that kind of, maybe that looks cool, but I kind of don't love it. I kind of want to stick with my grid approach. So what I want to do is maybe floor these. So if it's like 5.555, I'm going to just take it down to 5 so that these will be whole numbers instead of decimals. And that will add some restriction to my grid. So yeah, now they're all kind of laid out in a grid. It's kind of still random and still pretty sparse, but you at least have this kind of cool, like, you know, they're connected because they're in a grid. And yeah, I like that. That's cool. That's getting closer to what I'm kind of imagining in my brain. But I kind of don't love how they're just kind of randomly spaced out. So let me think about this. What I want to do is, so I think I always want to start sort of in the center, 0, 0, 0. So that's somewhere like right here. And then I think I kind of want to kind of build from that. So I don't know, think of it like maybe like a Lego set where I have maybe my base piece, and I can stick more cubes either to the left or the right or the top, and then kind of repeat that process. So how could I do that? I could do something like use like a 3D array that represents like which spots in my grid have a cube in them. Or what I could do is, so I'm trying to think ahead to like after I have a couple cubes, how do I want it to work? And I think what I want to do is maybe just try adding a cube to a random side. And so what I'm going to do is maybe pick a random cube and then stick a random cube to that first cube. So how might I do that? I think what I'm going to do is define, let me think about this. I might define a function that like checks whether a spot is already taken, maybe. So instead of adding a random cube, what I'm going to do is sample my array. So like const random cube equals random cubes. So the p5 random function takes an array and will return a random element from that array. At first, my array will only have one, so this will be just the one that it contains. But as I add more, it'll become more interesting. So then I want to add like a random cube to it. So I think I could either do like a random walk from a cube. So like add 1 or 0 to its sort of CRZ, or I could do like a random, maybe I can just give it a random chance to either grow left or right or up. I think maybe I'll do that. So const R, I'm using a lot of R variables today, but whatever, random 1. And then I'll say like if R is less than 0.3, then do something else. If R is less than 0.6, do something else. And otherwise I'll do yet a different thing. So let's think. So maybe I'll have let new cube R equals random cube R. Yeah, I think this feels about right. So I have R, actually CRZ, and then random cube dot C dot R dot Z. So I start out my new cube at the same position of the random cube I've chosen, and then given a random chance, I'll either increase the C, the R, or the Z. So either add the new cube to the left or to the right or to the top. So new cube C plus plus, new cube R plus plus, and new cube Z plus plus. So now new cube C R Z represents another position sort of in my grid that's next to one of my previous cubes. And next, what do I want to do? So I could just always add my random cube there, and maybe let's try that. Cubes dot push new cube C. Oh my god, I can't type. New cube C, new cube R, new cube Z. And so this will add 10 cubes, but they'll all be kind of based off of random neighbors. I don't think I'm quite done yet, but let's just see what this looks like. And yeah, okay, that's not the worst thing I've ever seen in my entire life. Oh, that's kind of cool, actually. But if you kind of count these, this isn't 10. This is 1, 2, 3, 4, 5, 6 cubes. Maybe there's a 7th back there, but it's not 10. And that's because some of these will overlap with previous cubes, and I think I kind of want to avoid that that process or that happening. And a couple ways I could do that. Again, I could use like a 3D array or something. I think I'm going to do something really brute force, and I think I'm going to say that that's okay because my grid is never going to be super large. It's at most right now it's going to be like, if I completely fill my grid, it'll be 100 cubes. So even if it was like 1,000 or even more than that, I think it would still be okay. But what I want to do is check whether there's a cube already at that location. So I think what I'm going to do is use the, what is it, like JavaScript array sum or something. Yeah, sum, and that takes a function that, yeah, okay. Basically, I want to check if anything in the array, if any cube in the array already has these coordinates. And so what I can do is maybe store a variable const spot taken or cube exists or spot available. Nah, whatever, spot taken. I'll just call it taken for now. Equals, and then what I want to do is cubes dot sum, and this is going to take a function. So I could define a function, but I think what I'm going to do is use a what's it called, a lambda or whatever it's called in JavaScript. It's like arrow function syntax that takes a cube and returns whether, let me do it this way, return cube dot c equals new cube c, and it's annoying, cube dot r equals new cube r, and cube dot z equals new cube z. Okay, so this variable spot taken will be true if any of the cubes in my array already are already in that array or in that spot. Okay, so what I can do here is maybe not push if not spot taken. So if it's taken, then I don't add the cube and I just keep trucking. And then the only other thing I want to do is maybe change this for loop. So right now it's only going to try to add a cube 10 times. But what I actually want is to loop until I have like a total of 10 cubes. So cubes dot, I think length is greater than or equal to 10. It's actually only equals, but the greater than kind of tells me like what direction I'm going. I kind of prefer that, even though it's not necessary. So I don't know, let's just try and see what broke. Let me maybe save this in case I have an infinite loop in there somewhere. So that didn't work at all. That's great. Cool. Love it. So what do I, greater than, while cubes dot length are, it's less than or equal to. So I do a straight up line with that greater than. Yeah, man, that's cool. I think there's something weird's happening here. Oh no, it's not. It's just like sort of on top of it. No, that's cool. Yeah, cool. I'm into this. Don't really want to count them, but it could be about 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's probably one like kind of behind it. Yeah, cool. This is neat. So I could do a couple things. I could, first of all, increase this number, and I could maybe move this down. So grid top Y, let's move it down to 250. Yeah, man, this is cool. I like that. It's kind of just like a random, I don't know, 3-dimensional cube shape. So it kind of grows from my 0, 0, 0 and grows out a little bit. You can think of it as like randomly sticking Legos on top of your old square. And I'm trying to think, like I'm trying to look at this and see if this is right. It kind of gets at that like MC Escher like paradox thing. Like I can't really tell what's happening here. And I don't know if that's because I did something wrong or if that's just because of how like the isometric projection works. So I've got this square here. Okay. I've got this square here. Okay, I think I see it. So it's like this square. No, this doesn't make sense, does it? All right, here's what I might do. I might, yeah, okay. So instead of doing that all in that loop, here's what I'm going to do. I'm going to say, I'm going to create like a function. Function, let me put it below draw just for like organization purposes. Function add random cube. And what I'll do is, yeah, maybe I'll just take some of this logic. I'm going to end up changing this, but so add random cube. So yeah, okay. So what I'll do is say let cube added equals false, I guess, and I'll say while I have not added a cube, while not cube added. There's probably other ways to do this. There's like definitely other ways to do this, probably better ways to do this, but whatever. So I have add random cube. I create a variable called cube added, and while that's false, I will try to add a random cube, and instead of this, if not spot taken, so here I'll say cube added equals true, so that next time it comes around, it cancels out of this while loop. All right, let's see if that works. So what I'll say is add random cube. So I should just see kind of 2 cubes now, and I do. Cool. So it's like choosing a random side of my starter cube to stick a new cube to. So maybe what I want to do next is like just say like mouse pressed or something, and in here I'm going to say add random cube. All right, so I start with my 2 and I'm going to click, and cool. So I'm doing this so that I can like more closely examine exactly what's happening and see if I can confirm in my own brain that I like it. And like that one was weird. Oh, I wish I could kind of go back. Oh, I can. So here's what I'm going to do. And just for now, I'm going to say like function key pressed, and we're going to say, how do I remove the last element from an array? So like JavaScript array remove last pop. Is that a thing? Oh, cool, it is. So let's try cubes.pop. So I can kind of like hit backspace a little bit. Yeah, whatever, we'll see if this works. So I can click and I can type, yeah, cool. So I have like a delete key. It's a little unfortunate that when I deleted it, like I can't just add it back, but oh, whatever, this will work. So I add something, so that works. Add something, that still looks like it works. Yeah, man, these all seem like they work fine. Wait, what was that one? Yeah, okay, so here's where it gets a little weird. This is where the overlapping nature of the cubes kind of bites us. And this cube was added as, so you can see, like, you can't really tell, was this cube a child of this cube, or was it a child of like something that's like below it? Is that a thing? Need backspace. Hey, I think I might just be overthinking. Oh yeah, see, okay. So yeah, you have like there's, because of the Z, you're going to have some overlapping cubes, and I think I might just let that happen. I think it's fine. So yeah, here's kind of the artifact I was seeing earlier, but I think that's normal. I think that's totally fine. Yeah, okay, cool. I think I've convinced myself that my logic is right, but my sort of, because we're using the isometric grid, you're kind of at the mercy of that. So it's going to have kind of the weirdness, and I don't know, I kind of like that actually. So like here's an example of the weirdness where there's kind of a hole in my structure, and yeah, that's okay. Yeah, I kind of like that. Cool. So from here, I don't know. How do I turn this into something that I'm actually like pleased with? So I'm fine with some of this. Maybe I get rid of this. Maybe what I do is I say, instead of mouse pressed or mouse or key pressed, maybe what I do up here. So first off, let's maybe make it look a little nicer. So start with cooler background maybe. And maybe that's too dark. Yeah, whatever. Actually, what I probably should do is like draw a grid, but I kind of just don't feel like it. Yeah, whatever. Gray is fine. So that looks cool. Maybe I'll do like old reliable, increase my stroke weight. There's like just a few like tricks that kind of always make a sketch look a little nicer. Yeah, I'm into that. That's cool. Another thing I might do, so I'm trying to think of like whether I want to try to animate this or if I want to kind of leave it up to random and have it be like a still image. What I might do is like if frame count, actually here's it's easier since it's kind of mostly static anyway. What I can do is add random cube and then change my frame rate to like 1 or something. And something's broken because of course, why wouldn't it be? Frame is not defined. Oh, well, that's because I didn't spell this right. Frame rate 1. So now we'll sort of see my structure building over time. And yeah, I don't hate that. It's kind of cool, kind of zen. I think maybe it's a little slow. Maybe let's increase it to like 5, maybe. See what that feels like. Yeah, I mean, I could see, waiting a minute and recording this as a GIF and posting that as my sort of January event. Well, really, it's yesterday's January event. And I might end up doing that, actually. I think that's kind of cool. Kind of just want to wait and see what it looks like after it's kind of all filled up. Yeah, I think we can just wait a second. Because eventually I'm pretty sure that this will eventually kill me, right? This will eventually, oh wait, no, because, right. So my original grid was kind of in my brain, like 10 by 10 by 10, but there's actually nothing actually stopping this from growing. So this will just fill the screen. And maybe that's cool, but that's not exactly what I'm going for because it just ends up kind of looking like these hexagons if you have too many of them. So I think maybe the animation is too much. So I think what I'll do is I'll kind of go back to the original idea of like doing it for a certain time. So like while cubes dot length is less than or equal to some number, let's just try something. Add random cube and let me take out my animation. So yeah, that's kind of cool. I started out with just 100, and so every time it'll be a little different. I think that's cool. I might end up just screenshotting a few of these and calling that my project. I'm gonna maybe move this up a little bit more. That's probably too much. Yeah, good enough, I guess. Yeah, these are cool, man. I like these. So I think that's about where I'm going to call it. I think that's probably what I'm going to post as my January event. I can get rid of some of this. I can get rid of some of this. I could save my computer a little bit of time and say no loop, since I'm just drawing the same thing every time. Doesn't really matter. Yeah, whatever. So yeah, I like this. This is cool. Let me think about this. So what else do I want to sort of do? So I played with animation a little bit. I could kind of move my squares over time, or my cubes. I could like start them out here, but then have them kind of move away from each other. That might be cool. I could do something like change their sizes, so I could give each cube kind of a random size. That might be cool, but I kind of like this kind of cube, like grid approach. I kind of want to obsess over the background a little bit, and it's good enough. So I've got my cube. Another thing I could do is, like right now, my RGB, it's all totally random. So I could like increase their R, maybe decrease their G, maybe just make their blue 0 for now. So now that's kind of gross, like yellow-green color, but you know, it has a different kind of visual flavor than my completely random colors. That's another thing I could play with, but I don't know, kind of like the random. So yeah, all right, let's just recap. So to recap, I set out with a goal of creating something with a 2D perspective, and I challenged myself to figure out how an isometric projection works. I stared at this shape for too long, and I got a lot of that working, but then I hit a brick wall with how the grid was laid out, and that required me to do some reading. So I googled like isometric grid to coordinates, and I read a few of these pages that if you're curious about learning more about like the isometric projection, I recommend reading through these more carefully. So that helped me out, but it probably made for not a very interesting video. So I did some time traveling and had to take a break halfway through because it was just taking too long. But the end result is like a working isometric 3-dimensional grid of cubes that ends up looking pretty interesting, if I may say so myself. So I'm pretty happy with this result, and you can play with the code a bit more and add things like animation, or more interesting color schemes, or kind of the interactive nature. So maybe clicking adds a cube, or maybe they animate in over time. For me, all of my cubes are connected. You could play with the idea of having more like disconnected cubes. That could be a cool thing to play with. Or you could go like to the really advanced stuff and go from like screen pixels back to map pixels, or like back to isometric pixels or coordinates. So for example, maybe clicking on a cube deletes it, and that would be a pretty challenging thing to do that I am not even going to try to do in this video. But if you're curious about how this all fits together, that could be something that you play with. But for me, I think this is about what I set out to do, so I'm pretty happy with this. So as always, if you have questions or comments or just want to say hi, you can comment in the video, or you can come to happycoding.io. That's my little website where I hang out. Come to the forum and come say hi, and I'd love to see what you're working on. But for now, I'm going to sign off and say thanks for watching this very long video. Thanks for time traveling with me, and have a great rest of your day. And thanks for watching. And as always, of course, happy coding.